Hello, my fellow scientists. Welcome to the study of calculus basics, calculus fundamentals. Today, we want to show that y prime is equal to cos x, given that y is equal to sin x from the definition of derivative. So that y prime is equal to cos x, given that y is equal to sin x from the definition of derivative. So, solution. Definition of derivative of function fx with respect to a is given by limit as h tends to 0 f of x plus h minus f of x, everything divided by h. So we let function fx to be sin x, then we substitute function f with sin x, limit as h tends to 0 of sin x into bracket h plus h minus sin x, which is function fx, everything divided by h, which is equal to limit. Now, using the rules of trigonometric function, the rule of the sum of sine function, we are going to get limit as h tends to 0 of cos x sin h plus cos h sin x minus sine of x. Now, from there now, we are going to get cos x sin h, limit of as it tends to 0 of cos x sin x plus cos minus 1 into bracket sin x. That is now factoring sin x here. That is what we are going to get. So, from the properties of limit, we can now distribute the limit inside this bracket. The limit, one of the property of the limit is that it is a distributive property. So we limit of as h tends to 0 of cos x, limit as h tends to 0 of sine of h over x plus limit as h tends to 0 cos h minus 1 over h multiplied by limit as x tends to 0 of sine x over h. Now, limit as h tends to 0 will give us 1, and the limit as h tends to 0 of cos x is just cos x. So cos x times 1 is equal to cos x. Limit as h tends to 0 of this function here, this will give us 0. Limit as limit as sin h over h tends to 0, it is 1. 1 times cos x is equal to cos of x. Limit as cos h minus 1 over h tends to 0 is 0. 0 times sin x over h is 0. So we are going to get a derivative as f as cos x. So the derivative of sin x with respect to x is equal to cos x using the definition of derivative, which says that limit as h tends to 0 of function x plus h over h minus fx. Yeah, that is the definition of the function. Secondly, we want to show that derivative of cos y with respect to x is equal to negative sin x from the definition of derivative. So derivative of function of fx is given by limit as h tends to 0 of function x plus h minus f of x. Here we let function fx to be equal to cos x. we let our function fx to be equal to cos of x, limit as it tends to 0 of cos of x plus 8 minus cos x minus cos of x. This function of x, we have let it to be cos x. So minus cos of x will be given by limit as h tends to 0, using now the sum of the trigonometric function, the sum of sine, the sum of cos. Using the sum of cos, we are going to get limit as h tends to 0 of cos x multiplied by cos 8 minus sine x multiplied by sine of x minus cos x, everything over 8. Everything here divided by 8. Now, using the property of limit, which tells us that limit is a distributive property, so we separate this. Limit can get inside from that property of limit. So we are going to get limit as it tends to 0 of cos x multiplied by cos 8 over 8 minus limit as h tends to 0 of sin x sin 8 over 8 minus limit as h tends to 0 of cos x. Now, at this point here, we have cos x and cos x, so we can group this together and we factor cos x outside, so that here we will be left with cos 8 minus 1, this one. The limit of 8 at it tends to 0 of cos x into bracket cos 8 minus 1 divided by 8 minus limit as h tends to 0 of sin x sin 8. Now, when we take limit here, this function all of it tends to 0. Taking limit here, this one. So taking limit, the whole part here, this part tends to 0. So cos x times 0 will be 0. This other part, the final part here, this one, limit as h tends to 0 of sin x sin 8 over 8 will tend to 1. So negative 1 times sin x times 1 will give us negative of sin x. Hence, that is the derivative. So today we have looked on how to find derivative of trigonometric function of sin x and cos x using definition. What is needed, it is simple. First of all, you use the definition of the function of derivative, which is defined as limit as h tends to 0 of function f of x plus h minus f of x h, which is, and then you let f of x to be sin x, then you substitute here where you have x, you write sin x, limit, you put the limit, then you use the sum, the trigonometric rule, then you use the trigonometric sum rule, which tells us that sin of x plus h is cos x sin x plus cos h sin x minus sin x. Then you over x there. Then you factor sin x here. You factor sin x here to be left with cos h minus 1, that one. Then using the property of limit, you can separate here limit as h tends to 0 of cos x, limit as h tends to 0 of sin h over h, plus limit as this one tends to 0. And now we are going to find out that here, this one will become 1, 1 times cos x is cos x. This part here will become 0, and 0 times sin x will give us 0. Hence, the derivative of y is equal to sin x is equal to cos x. If the other part, it is this one, again you use the definition of derivative as limit as it tends to 0 of function f of h plus of x plus h minus fx. Then you let function fx to be cos x. You substitute here. Again, you use the sum of trigonometric function of cos, which is given by cos x multiplied by cos h minus sin x multiplied by sine of h minus cos x, everything over h. Then you take the limit as shown here. Limit as h tends to 0 of cos x cos h over h minus limit as h tends to 0 of sin x sin h, limit as cos x over h tend to 0. Then this part here, of course, after factoring cos x here, this part here tends to 0. This part here tends to 1. So sin x times 1 times negative 1 is equal to negative 1. So that is the end of the proof. Thanks so much for taking time to watch this channel. Bye-bye. Kindly consider liking it, subscribing, and sharing so that we may continue learning together the fundamental of calculus, which is key in further learning of mathematics. For more studies, you can tune on to my YouTube channel at Luke Aaron. My channel name is Luke Aaron. Luke Aaron 1. Luke Aaron 1 is my channel name. You can reach out to me through this Luke Aaron 1, and you are going to get more studies, particularly on derivative of trigonometric function, whereby we have done step-by-step method, which is easy to follow and understand at your own time. Thanks so much. See you next time as we continue with our learning of the derivative of trigonometric function using the method of definition of derivative.